Welcome dear students. In this video I will discuss equilibrium of a three-force body. Now consider this body. Three forces are applied on the body F1, F2 and F3. Now assume that the line of action of these forces F2 and F1 they are intersecting at point D. Okay. Now the moment of F1 and F2 about this point are 0 because these forces are passing through this point, so they will be having zero moment because there is no vertical component. Okay, now if the body is in equilibrium, so what it means, it means that the sum of the moments of F1, F2 and F3 about any axis must be 0. Okay, so if there is some moment, then it means that body is not in equilibrium. So if body is in equilibrium, then the moments of these three forces about any axis must be 0. So it follows that moment of F3 about D must be 0 as well, because the moment of these forces is 0 because they are intersecting at this point. So that means that the moment of F3 should also be 0, and the moment of F3 about D 0 means that F3 must pass through the same point D. Okay, so this means that the line of action of three forces must be concurrent. So this is the first condition of equilibrium of a three-force body, that the line of action of the three forces, that is F1, F2 and F3, must be concurrent. That is, they should pass through the same point or parallel. Okay, so that means that for equilibrium of a rigid body in 3D, 6 scalar equations are required, because summation of f should be 0 and summation of m should be 0. So we have three components for each. So that means that summation of fx, fy and fz should be equal to 0. Similarly, summation of mx, my and mz should be 0. That means that these equations can be solved for no more than 6 unknowns, because 6 equations, so we can solve them for 6 unknowns. Okay, we generally represent reactions at supports or connections. So the unknowns generally are reactions or connections at supports. Okay. We can also write in the vector form. So then we have only two equations. Summation of f is equal to 0 and summation of moment about any point, which you can also write as r cross f, should be 0. Now as we have seen the reactions at supports and connections for 2D, similarly in this slide the reactions at support and connections for a 3D structure are shown. So suppose if we are having this type of supports, ball type of support, or your body is placed on some frictionless surface, then there is only one reaction which is normal to the surface, this surface. Okay, similarly if we are having some cable, so then we have tension force, and the tension force will be in the line of the cable. Okay, now suppose if you are having a roller type of support, or say wheel on rail, so in that case there are two components. Okay, so that is, suppose this is in this direction moving, suppose this is moving, initially moving in this direction, then we will be having the reactions at fy and fz. Okay, and if the body is supported on some rough surface, or in case of ball and socket joint, we will be having three unknown reaction forces. So this is how you can draw reactions for 3D bodies. Similarly, suppose you are having some universal joint type of structure. So again, you will be having three unknown forces plus a moment. Okay. Now for fixed support, you will be having three unknown forces plus three moments. Okay. So you will be having six unknown for the fixed support. Sometimes you come across with these problems. Okay. So hinge and bearing supporting. So in that case, you will be having two forces. So we will um, we will not consider the axis of this. Okay, so we will be having Fy and Fz, similarly My and Mz. And now for this type of forces, pin and bracket joint and hinge and bearing supporting axial thrust and radial load, we will be having two moments, My and Mz. Okay, because in the x direction this is moving. Okay, so we will not having Mx. Otherwise, we will be having all the reactions Fx, Fy, Fz, and My and Mz. So you should remember this whenever you are drawing the supports. So just remember this, and whenever you see, so suppose you got in your problem this type of support, then you can immediately draw these reactions. Now consider this problem. Problem is the uniform 7-meter steel shaft has a mass of 200 kg. As you can see, this is the steel shaft and is supported by a ball and socket joint at A. So here we are having a ball and socket joint. Okay, the ball and B rest against the smooth vertical walls. So other end is resting on these walls. Compute the forces exerted by the walls and the floor on the ends of the shaft. So this is the free body diagram. So at the ball and socket joint, as we have seen, there should be three unknown reactions. Okay, while at this there shall be two unknown reactions, Bx and By. Okay, so there shall be no reaction at Bz, as we have seen in the previous slides. Now this is the solution of this problem. So weight we can calculate m into g, and this distance, okay, and this unknown distance h you can calculate by simply applying the formula. So we know this distance, we know these three distances. Okay, so this h height comes out to be 3 meters. Now this position vector RAG, because this is our origin. Okay, this is our origin. Okay, so this is A and this is G. So RAG will be minus 1 I. So in x direction this is 1. Similarly minus 3 J plus 1.5 K. Similarly we can calculate RAB, which will be minus 2I minus 6J and plus 3K. Now suppose you want to calculate moment about A. So for equilibrium, summation of all the moments about A should be 0. So RAB cross BX plus BY means the moments of this, because of BX and BY should be 0, plus this moment because of this force W should also be 0. So we have RAB cross Bx plus By plus RAG cross W should be 0. Okay, so this we have already calculated. Sorry, RAB and Bx and By, they are unknown. Similarly RAG, this we have calculated, and W we have calculated. Now you can write this in the form of determinant. So IJK minus 2 minus 6 3 and Bx By and B, that is 0. Similarly we can write for this So our final equation will be this. Now equating the coefficients of I, J and K to be 0, we will get Bx as 654 Newton and By as 1962 Newton. Similarly, the summation of all the forces should also be 0. So we can have summation of Fx is equal to 0, summation of Fy is equal to 0, summation of Fz should be 0. So this is X, this is Y and this is Z. So by solving the equations, these three equations, we will get Ax as 654 Newton, Ay as 1962 Newton and Az as 1962 Newton. So finally we can calculate A as under root ax square plus ay square plus az square. That means 654 square 1962 square plus 1962 square. So that will be 2850 Newton. So this completes the problem. So this is all for this video. Thanks for watching.